my name is KALPITHA and I'm here to talk about the experiment our group has chosen to do for the Beckett experiment. Okay, the introduction is the thermochemistry fireproof balloon experiment explores the principle of heat transfer and combustion reaction. By encapsulating a balloon with a fire-resistant material and subjecting it to an external flame, we aim to investigate the thermal energy exchange involved in this process. Understanding the thermochemical reactions occurring within the balloon provides valuable insights into fire resistance and heat dissipation. The objective of this experiment is to analyze the heat transfer and combustion reaction in a fireproof balloon to understand a fire-resistant material effectiveness.
So the apparatus we need for this experiment is 2 balloons, a candle, a lighter and some water.
So the first step is we are going to label it as A and B. So the next step is we are going to inflate balloon A and tie it up.
Next, we are going to fill some water in balloon B, inflate it and tie it up. Next, using the lighter, light up the candle and hold balloon A closely towards the flame.
And then we are going to observe it. Now we are going to place balloon B on top of the flame and observe the results.
Okay, for the balloon A, the heat will be transferred from the candle into the air inside the balloon A, which will cause the air to expand and the balloon will burst within a few seconds.
With this situation in balloon B, the heat is transferred to the balloon and is absorbed by the water. So the air doesn't expand and thus the balloon doesn't explode.
Thermal conductivity refers to a material's inherent capacity to transmit or conduct heat. It is one of the 3 ways to transmit heat. The other 2 methods are convection and also radiation. Heat exchange process can be measured using appropriate radiation equation. Thermal conductivity occurs by molecule vibration and contact instead of the material itself moving in its whole. Heat flows through a temperature gradient from a region of high temperature and high molecular energy to an area with low temperature and also low molecular energy. This heat flow will continue until thermal equilibrium is achieved, and the rate at which the heat is transferred is dependent on the size of the temperature gradient in addition to material's specific thermal properties. A material's thermal conductivity is highly influenced by a wide range of factors. These factors include the temperature gradient, material categories, and also the distance of the heat path. Materials can be divided into three categories when discussing thermal conductivity trends: gases, non-metal substance, and also metallic substance. This difference in heat transfer abilities of these three categories can be attributed to differences in their structure and also molecular motions. Because gases molecules are not tightly packed as in their solids, their relative thermal conductivities are lower than the solids, and their heat transfer is heavily reliant on the free movement of molecules and molecular velocity. Thermal conductivity is an important component of the material to material relationship, and understanding it allows us to get the best performance out of the materials we use in all aspects of our life. Specific heat capacity refers to the quantity of heat needed to raise the temperature per unit per mass. When the same amount of energy is added to two substances, the substance with the higher specific heat capacity will have less of an increase in temperature. A higher heat specific capacity also means that a substance must lose more energy in order to decrease in temperature. The high heat capacity of water is due to the factor that it takes a lot of energy to separate water molecules. The physical bonds are very strong. Water has heat capacity about 4 times of compared to air.
In conclusion, the thermochemistry fireproof balloon experiment sheds light on an integrative interplay between heat combustion and fire-resistant materials. Our findings contribute to a deeper understanding of mechanisms that allow certain materials to withstand intense heat, protecting the balloon from bursting. This knowledge has practical implications for enhancing fire safety measures and developing materials resilient to high temperature environments. Through this experiment, we have gained valuable insights into the thermochemical aspects of fire resistance, paving the way for advancement in safety technology and material science. Thank you.